Hello everyone, welcome back. This is lecture 3 of electrostatics and second part of Coulomb's law. In this lecture, I will be teaching you principle of superposition. We'll do some questions based on that, and after that I will teach you null point. I will prefer that before seeing this lecture, just go and see the first part of Coulomb's law, in which I have taught you what is Coulomb's law, what is vector form of Coulomb's law, and we have done some basic problems. So without wasting any time, let's start principle of superposition. Principle of superposition. Now, what is principle of superposition? Let's say we are having two charges Q1, Q2, which are present at a distance R12. If I ask you what force Q2 will apply on Q1, let's say both are positive. You will say the force applied by Q2 on Q1 will be, it will repel along the line joining with a force K Q1 Q2 by R12 square. Is it? Which I am writing as F on 1 due to 2. Clear? Now, if I bring a third charge in the surrounding, if I bring one more charge Q3, and distance between Q1 and Q3 is R13. Now what will be the force between Q1 and Q2? All of you think. What will be force between Q1 and Q2? So keep in mind, if I bring a third charge in the surrounding, the force between Q1 and Q2 will remain unaffected. Whatever force Q2 was applying on Q1 before Q3, same force Q2 will apply on Q1 if I bring Q3. So the question is, sir, what will change? Now when Q3 will come, it will also apply a force on Q1. So now there will be two forces on Q1. Q3, let's say Q3 is also positive, so Q3 will also repel Q1. This is force on 1 due to 3. So what has changed? Net force on Q1 has changed. The force between Q1 and Q2 does not depend upon the presence of Q3. Q3 is there, Q3 is not there, doesn't matter. For example, let's say you are standing on ground. On you, mg will act. Is it? Mg is acting on you. Then when you will go in water, you feel light. Does mg decreases? No. When you go in water, a buoyancy force acts on you. So net force on you decreases. You are standing on ground. Earth is pulling you down with a force mg. When you go in water, you feel light. Is it? So does mg decreases in water? No. I taught you in the previous lecture, gravitational force does not depend upon medium. So on you, same force will act due to earth mg. But a new buoyant force will act on you. So now the net force on you will be mg minus b. That's why you feel light. Clear? Same thing is happening here. The force between Q1 and Q2 will be same if I bring Q3. But what will change? The net force on Q1 will change. Now the net force on Q1 will be the vector sum of these two forces. Is it clear? Now if I bring a fourth charge Q4, and let's say Q4 is also positive and this distance is R14. Now if Q4 will come, it will also apply a force on Q1. This force will be F on 1 due to 4. Now net force will again change. But the force due to 2 and whatever force 3 applied on 1, that will remain same. This is known as principle of superposition. What is that? The net force on any charge will be the vector sum of all the forces due to the charges present in the surrounding. Is it clear to everyone? This question can come in a certain region. This question can come. Is it clear? Let's write the statement. The statement is, you can just make this diagram for your understanding, both you can draw. Clear? So what statement you will write? The net force on a charge will be the vector sum of all the forces acting on it due to all the charges present. This is principle of superposition. The net force on a charge will be the vector sum of all the forces acting on it due to all the charges present. Is it clear? You can write the mathematical form also. If we have a charge Q1, in the surrounding I bring a charge Q2, Q3, and let's say Qn, n charges are there. So on this charge, all the charges will apply force. Q2 will apply force, Q3 will apply force, Q3 will apply force, Q4 will apply force. This is force on 1 due to 2. This is force on 1 due to 3. This is force on 1 due to nth charge. So what will be net force on 1? You will write net force on 1 will be force on 1 due to 2, vector sum force on 2, force on 1 due to 3, plus force on 1 due to 4, force on 1 due to 5, force on 1 due to nth charge. And what sum? Vector sum, because force is a vector quantity. This is principle of superposition. Clear? You can write this. Pause and write. Okay. Let's do some question based on this. Question number 1. Find net force on the top charge Q naught. You have to find the net force on the top charge Q naught. So we are having a right angle triangle. On the corner I have kept a charge Q, and on the top the charge is Q naught. It's an equilateral triangle of side A. Find the net force on the top charge Q naught. Pause and try. Done? So whenever you are solving question which contains multiple charges, you have to apply principle of superposition. What is that? The net force on any one charge will be the vector sum of all the forces acting on the charge due to other charges. Okay. So first what you will do, you will find how many forces are acting on Q naught. So I can see two more charges, Q and Q. Positive charge, it will repel. Positive charge, it will repel. First let's find out the force. Okay, so this is positive. I will prefer you all, the charge on which you are finding the force, go and sit there. So you are here. Okay. Now this is positive. We know positive repel, and along the line joining. So this positive will repel this positive along the line joining. This is the line joining the charge. So along the line joining. So what will be this force? K, Q naught by side of the triangle is A square. Clear? One more charge is there. This will also repel this charge. How this will repel? This is positive. It will repel along the line joining. It will also repel along the line joining. By what force? K, Q naught by A square. So we got two forces. This one and this one. So what will be net force? This plus this. Is it? No. Force is a vector quantity. So we have to do what? Vector addition. Now, if you look at this triangle, it's an equilateral triangle. All angles will be 60, 60, 60. And if you pay attention, the angle just opposite to it will be vertically opposite. This will also be what? 60. So we are having two vectors at what angle? 60-degree angle. So what will be resultant? So vector 1, vector 2 at 60 degree. So we know how to add vectors, under root a square plus b square plus 2ab cos theta. Now to reduce your time, what you do, instead of writing this big term, you assume this term to be f. If this is f, this is also equal, is it? So this is also what? F, both are equal in magnitude, na? So if this is F, this is also F. So basically we are having two vectors F which has magnitude F and F at 60 degree. So net force will be what? Net force will be vector summation of these two under root of A square plus B is also F, B square plus 2 into A into B into cos 60. Cos 60 will be 1 by 2. So F square root 3 F square, which will be root 3 F. F will come out. Now you put the value of F. What is the value of F? We have assumed F to be K Q Q naught by A square. This was F. So this will be the net force. So net force will be root 3 K Q Q naught by A square. This is the magnitude of net force. What will be direction? So if you look at this diagram, on this charge, two forces are acting like this and both the forces are equal. One force is like this, one force is like this. Angle is 60 degree. So when two equal forces act, the body go exactly in between. So the charge will go exactly in between. Is it? So the net force will be what? Exactly in between. So the net force direction will be like this. This is direction of net force. This is direction of net force. So in vector form, how will you write? You will write net force is equal to K Q Q naught by A square root 3 and net force will be exactly in between. So J cap. This will be the vector form. Is it clear? I hope you understood. Fine. Let's do some more problem. Find net force on Q naught in the following cases. Same question. Find net force on Q naught in following cases. You have to find net force on Q naught in the following cases. Again we have an equilateral triangle. Here we have a charge Q. Here we have a charge Q. Here we have a charge Q naught. Let's make this minus negative charge. Okay. Equilateral triangle of side A. Next question. We have a square of side A. This is a charge Q. This is charge Q. This is charge Q. This is charge Q naught. Or let's do one thing, make this charge negative. And again it's a square of side A. Find the net force on Q naught. Pause and try. Done? So now I have to find the net force on Q naught. So you will sit here. This is positive, this is positive. So positive will repel. So this will be repelled. By what force? K Q Q naught divide by what is distance between them? A. Triangle of side A square. Then this is negative, this is positive. Negative will attract positive. Negative will attract along the line joining. By what force? K Q naught by A square. No one will write minus sign. I have told you while writing K Q1 Q2 by R square, by applying this formula, always take the magnitude. Minus will tell direction, that we will find out by common sense, attraction or repulsion. Clear? I hope you all have that. Okay. Now this is 60 degree, 60 degree, 60 degree. This line, straight line, total angle is 180. So this will be what? 120 degree. Is it? So now we are having two vectors at 120 degree. And if you see both are equal, if I assume this to be F, this will also be what? F. So we have two vectors F and F at 120 degree. So what will be net force? I want you all to remember this result. When two equal vectors are at 120 degree, the result comes the same. The magnitude of the vector, the magnitude of this resultant vector will be F only. Anyway, you can solve and check. So net force will be under root A square plus B square plus 2AB, FF will be F square, and cos 120 is minus 1 by 2. So F square minus F square, this will be root F square, which is F. And what is the value of F? K Q naught by A square. This is the net force acting on Q naught. and again both vectors are equal, so the net force will be what? Exactly in between. Is it? Both are equal in magnitude. When two vectors are equal in magnitude, their resultant comes exactly in between. So resultant will be exactly in between. This will be the net force. At what angle? 60 degree. Total is 120, na? So this will be what? 60 degree. If anyone want to write in the vector form, you can write in the vector form. How will you write in the vector form? So the net force which we got, this net force, whatever we got, is coming at 60 degree from the x-axis. I hope you all know how to take component. So this f will have two component. Along the x-axis, f cos theta, y-axis, f sin theta. So along x, what you will get? F net cos 60. Along y, what you will get? F net sin 60. Is it? So what will be the vector form? So net force in vector form will be F net cos 60. What is F net? F net is k q q naught by a square. So k q q naught by a square. Cos 60 will be 1 by 2. This is in x direction, plus x direction. So I cap. Plus net force sin 16 y cap, j cap. So k q q naught by a square. Sin 60 is root 3 by 2. This is in what direction? J cap. This is the vector form of the net force. This is the vector form. Is it clear to everyone? Okay, next problem. I hope you have paused the video and solved the next question. Okay, look at the next problem. Again, I am asking the net force on Q naught. Now here we have three charges other than Q naught. Okay, again you sit on this charge Q naught. You be here. Positive will repel positive. So this and along the line joining. So this positive will repel Q naught down. Is it? By what force? K, Q, Q naught. And it's a square of side A. This will be A square. Next, this charge will also repel by what force? K, Q, Q naught by A square. And this is negative. Negative charge attract positive along the line joining. So line joining them will be diagonal. So this negative charge will attract Q naught by what force? K, Q, Q naught by, I think most of you wrote A square. We take the distance between the charge and this is not A. Is it? What will be this distance? Distance between the charges? So the side of this is A. So if I join these two, you can see a right angle triangle of which this is hypotenuse. So what will be this? Root of perpendicular square plus base square. So this is root 2a. So k q1 q2 upon distance square. What is root 2a square? This is root 2a. So root 2a square will be 2a square. Is it clear? And this will be exactly in between, diagonal. Now I don't want to write these big terms. So what I will do, I will assume this quantity to be f. If this is f, this is also f, equal in magnitude. So k q q naught by a square is f. What is this? K q q naught upon 2a square. So this will be f by 2. Is it clear? So basically we are having three vectors, f right, f down, and here we have f by 2. Again what we will do? We will add all the three forces with the vector rule. Now what I will do, now we have three vectors, but formula we have for two vectors. So I will take two vectors. Now while taking two vectors, you have to be smart. You cannot take these two and solve. है ना? They are at 135 degree. So what you do, you take these two. So you can see two forces at 90 degree. What will be result? Under root of a square plus b square plus 2ab cos 90 is 0. This is root 2f. And I told you when two forces are equal, the resultant of that two is exactly in between. So this root 2f will come exactly in between root 2f. Now root 2f and f by 2 both are opposite in direction. I got the resultant of f and f. Now I have two vectors, root 2f, and opposite will be what? And opposite I have f by 2. So when two vectors are opposite in direction, directly we can subtract. If you apply the vector rule, same thing will come. Net force will be root 2f minus f by 2. You can take f common and you will get root 2 minus 1 by 2. And you can put the value of f. What is the value of f? K q naught by a square root 2 minus 1 by 2. This will be the magnitude of net force acting on q naught. You can just copy, pause and copy. Is it clear? Fine. Let's move to next question. Okay. So next question is a bit interesting question. Now the question is, we are having a clock. Now all the digits I have changed with charge. For example, this is 1 coulomb charge, 12 coulomb, this is 2 coulomb, 3 coulomb, 4 coulomb, 5 coulomb, 6 coulomb, 7 coulomb, 8 coulomb, 9 coulomb, 10 coulomb, 11 coulomb. And at the center I am keeping a charge which is 1 coulomb. And the radius of this is 1 meter. I want you all to find net force on 1 coulomb, center 1 coulomb. Find net force on center 1 coulomb charge. Okay, in terms of K. In terms of K. Okay, you can write the answer in terms of K. Pause and try. Okay. So what I will do? See, look at this charge. Look at this 1 coulomb charge. 12 coulomb will repel it down along the line joining. So 12 coulomb will repel 1 coulomb down by what force? K. 12 into 1, K, Q1, Q2, 12 into 1, divide by distance square, 1 square will be 1. So what you will get? 12K. Is it? K, Q1, Q2, 12 into 1, divide by 1 square. So 12K. Now, come to 11 coulomb, or let's come to 6 coulomb. What 6 coulomb will do? It will also repel. Both are positive. By what force? K, Q1, Q2, 6 into 1 by 1 square. So this will be 6K. Clear? Then 11 coulomb, with what force 11 coulomb will repel? Along the line joining. K, Q1, Q2 by 1 square, 11K. I thought you understood the trend. 5 coulomb repel away. By what force? K, Q1, Q2 by 1 square. This will be 5K. In the same way, 10 coulomb will apply a force. 10 coulomb will apply a force 10K, 4 coulomb will apply a force 4K, 9 coulomb will apply a force 9K, 3 coulomb will apply a force 3K, 8 coulomb will apply a force 8K, 2 coulomb will apply a force 2K, 7 coulomb will apply a force 7K, and 1 coulomb will apply a force 1K. We are having 12 vectors. What you do, you take 12 and 6, 12 down, 6 up. So net force will be 12 minus 6, 6K down. You take 11 and 5, 11 minus 5, what you will get? Again 6K. And one thing you keep in mind, between all two forces angle is 30 degree. Is it? We have 12 divisions. Total angle is 360. So 360 by 12, each angle will be 30 degree. Fine. Then, so I have taken 12 and 6, 11 and 5, 10 and 4. Again, you will get 10 minus 4, 6K. Is it? Then we have 9 and 3. What you will get? Again 6K. Then we have 8 and 2. Again 6K. Then we have 7 and 1. Again 6K. And all angle is 30 degree. 30, 30, 30, 30, 30. Now we have to solve 6 vectors. We have to be very, very smart. I cannot take any and solve, okay? It will increase my calculation. We can do, it will increase the calculation. So what you do, see, you take 6k and 6, not this one second. You take this 6k and this 6k. Why? Because angle between them will be 30, 30, 30, 30, 120. I told you before this problem, I told you when two vectors are at 120 degree, the resultant of that comes exactly in between. And resultant comes same. They are equal. When they are equal, resultant comes in between. And if the angle is 120, resultant comes same magnitude. So 6k at 120 degree will give me 6k and exactly in between. Is it? So this 6k and 6k, what will be exactly in between? They are at 120. So this is 60, this is 60. So result will come exactly in between. So 6k will give me 6k exactly in between. Now we have this 6k and this 6k. They are at what angle? 30, 30, 60 degree. You keep in mind, when two equal vectors are at 60 degree, their result comes root 3 times of any one vector's magnitude. You can solve and check under root a square plus b square plus 2ab cos theta. You will get root 3 times 6k. So result of these two will be in the same direction, exactly in between. And how much? Root 3 times of 6k. And already we have 1 6k here. Already we have 1 6k here. And we have 1 6k bottom also, 6k. Now you can see that these three vectors are in same direction. So what you will get? 6k, 12k and root 3 6k. So 12k plus root 3 6k and down will be 6k. Clear? Now you have one vector, second vector at 90 degree. You can write under root a square plus b square plus 2ab cos 90. You will get the answer. I am writing in vector form and leaving it. So net force in vector form will be 12k plus root 3 times 6k. This will be in I cap minus 6k in j cap. This is minus j, na? So minus 6k j. Clear? Understood? Fine. If anyone have doubt, please write in the comment section. I will explain, no problem. Okay, let's do some more problems. Do these questions fast. Question is, find net force on Q naught. Q. At the center I have a charge Q naught. Distance is A. Question number 1. Question number 2. We have a equilateral triangle. Charge is Q. And at the centroid I have kept a charge Q naught. Again, the side of the equilateral triangle is A. Third question, square having charge Q. At the center we have a charge Q naught. And again the side of the square is A. Question number 4. Q. At the center we have a charge Q naught. It's a regular hexagon and all sides are A. All sides are A. Fifth, it's a regular pentagon. Regular pentagon Q. At the center we have a charge Q naught. Sixth, again it's a regular pentagon Q. At the center we have a charge Q naught. This distance is A. I want you all to find net force on Q naught. Pause and try. Done? Okay. Question number 1. This positive charge, this positive charge. So this positive will repel by what force? K, Q naught by A square. What about this positive? Repel by what force? K, Q naught by A square. You can see both the force are equal and opposite. Net force will be 0. So in the first case, net force on Q naught will be 0. Clear? Both are repelling, equal distance, equal charge, net force will be 0. Come here. What about this? Positive charge will repel it down. This positive charge will repel it. I told you, sit on the charge and check they are repelling or attracting. If they are repelling, repel them along the line joining. Attracting, attract along the line joining. Again, this is positive, repel away along the line joining. Forces are equal, distance will be equal. I hope you all know that this distance comes out to be a by root 3. Clear? You can make a right angle triangle. This is a by 2. This is 30 degree. Is it? You can apply sine theta and you can get cos theta. Okay. Draw a right angle triangle. This is a by 2. This is 30 degree. So cos theta will be a by 2 by this. So you will get a by root 3. Okay. But anyway, in this question you can see all the three forces are equal. Is it? Because distance same, charge same. So all the three forces will be equal. This force and this force. So here what we are having? Here we are having three forces. Down F, in this direction F, in this direction F. What will be the angle between the forces? You can see we have three divisions. So out of 360 degree, if we have three divisions, this will be 120 degree, this will be 120, this will be 120. I told you when we have three vectors, take any two. If you take the top two forces, they are at 120 degree. I told you when two equal forces in magnitude are at 120 degree, resultant comes exactly in between and same resultant we get. So F and F will give me F exactly in between. Now one F up, one F down, cancels out. Again I got net force 0. Come to third problem. This positive will repel Q naught. This positive will repel Q naught. This positive repel along the line joining. This positive repel along the line joining. All the forces equal. These two cancel. These two cancel. Again net force 0. Is it? Same here. This will repel. This will repel. Cancel out. This will repel. This will repel. Cancel out. This will repel. This will repel. Cancel out. Is it? Again net force is 0. Have you observed one thing? At the symmetric positions, net force is 0. Write this statement. All of you write. At the symmetric positions, net force is 0. No need to solve from the next time. If you see that about a charge, if the other charge distribution is symmetric, the net force will be 0. Come to question number 5 and 6. Pause and write. Question number 5 and 6. I think, just write in the comment section, how many of you got for question number 6 answer 0, but for question number 5 KQ, let's say this distance is A, KQ Q naught by A square. If you got this, just make a big cross, because you have done mistake. Listen very carefully what mistake you have done. Okay, see, I told you symmetric point net force is 0. Okay, you know what mistake you have done? First come to question number 6. You thought that this positive will repel, this positive will repel, they will cancel out. This positive will repel, this positive will repel, they will cancel out. But it's a regular pentagon. It's not a square. These four charges are not at the corner of a square. In pentagon, the angle between two sides will be what? 72 degree, 360 by 5. Don't do this mistake. This is not at the corner of a square. This will repel, angle between them will be, then this will repel, between these two angle will be 144 degree, not 180 degree. For vectors to cancel out, if they are equal, they have to be at 180 degree. It's not 180. I hope you are understanding what I am saying. So in this regular pentagon, here I have kept a charge Q naught. This is Q, 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 Q. This will repel, this will repel, this will repel, this will repel. They are not exactly opposite. Answer will not come 0. In fact, in the previous problem, in this problem answer will come 0. In this case answer will come 0. Positive will repel, this positive will repel, this positive will repel, this positive will repel, this positive will repel. All will be at 72, 72, 72, 72 degree. All forces 72, 72, 72, 72, 72. About this center, it's symmetric distribution. About all forces will be equal. F, F in magnitude. F, F, F. Direction is different. So about this point, all will be symmetric. So here net force will be 0. Here net force will be 0, but not in this case. They will not cancel out. So how to solve? How to solve? Sir, we don't know what is the value of 72 degree. How to do? Listen how to do. Here what is the charge? 0. Can I write 0 as Q and minus Q? Can I write 0 as Q and minus Q? Anyway, net will be 0. So I am writing 0 Coulomb as Q comma minus Q. Now Q, 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 Q. These 5 charges about Q naught is symmetric. So these 5 charges will cancel out their force. If you see, these 5 charges is exactly same this problem. These 5 are not giving any force because about Q naught they are symmetric. So this will not give any force. So this 5 will not give any force. It means this diagram will be equivalent to one charge at Q naught and one charge at here, which is minus Q. Because these 5 will cancel out the force. The net force of these 5 will be 0 because of symmetricity. Like here we got 0. Only this minus Q will apply force. So now it's easy to find out. What you will write? You will write negative charge, positive charge. It will attract by what force? K, Q, Q naught. This distance is given A square. This will be the net force on Q naught. You can use this in multiple problems. Whenever you find that angles and all we don't know, and at some position the charge is 0, you can write that 0 as Q and minus Q. Or according to problem you can write. The net charge will be 0. Net charge should be 0. Just write in this way, Q and minus Q. See how simple it became. These 5 due to symmetricity will not give any force. Effectively only who will give force? Minus Q. So I removed other charges and I just wrote minus Q and I calculated the net force. I hope you all understood. Is it clear? Okay. One more question. We have a ring having uniform charge distribution and total charge is Q. And at the center I have kept a charge Q naught. What will be the force on Q naught? You will say, sir, because of symmetricity, the net force on this charge Q naught will be 0. Correct. This element will push it down. This element will push it up. This element will push it right. This element will push it left. Same, this element in this direction, this element in this direction. And they all will be cancelling out each other. So net force will be 0. But one second. Let's say I'm standing right now. One person is pulling me in this direction, one person in this direction with same force. On me net force will be 0 because 10 Newton, let's say 10 Newton, 10 Newton. Net force will be 0. But I will feel what? Tension, stretching I will feel. Yes or no? You think here we have a charge Q naught. From third law of Newton, if these charges are repelling, like this element is repelling Q naught down. So at the same time, Q naught is also repelling this element up. Q naught is also repelling this element down. Q naught is also repelling this element. So all the elements are also being repelled by Q naught. All the elements are also being repelled by Q naught. So this ring will have force at every part of it. What is the net force on the ring? You will say 0. All the forces will cancel out, means this force will cancel this force, this force will cancel this force, this force will cancel. So there will be a force on the ring which will be cancelled out by diametrically opposite force. Clear? This is the same case as a force on my hand. I will feel tension. In the same way, this ring will also feel tension. That tension you have to find and you have to write in the comment section. I will post solution for this. I want you all to find what will be the tension in this ring. You can take the radius to be r. Clear? Pause and write. So net force on Q0 will be 0. Net force on the ring will be 0. But as there is force on each element of the ring will experience what? Tension. That tension you have to find out. Clear? Okay. Next. Now we'll do some questions based on null point. Null point means the point where a third charge will experience no force. Okay. So write null point or equilibrium point. Question number 1. Let's understand this concept with problems. Okay. Let's say we have two charges Q and Q. If I ask you, where should I keep a third charge and distance is L? Where should I keep a third charge Q0 so that it does not experience any force? Without solving, you will say, sir, at the center. If you keep a charge Q0 at the center, this will repel, net force will be 0. But if I make this charge 4Q, now you find, question is, find the point where F net will be 0 on Q0. So I am giving you a charge Q0, you just keep anywhere in the entire space where net force will be 0. Pause and try. Okay, done. So before starting this, you make 3 regions. First you make a line joining these two. One thing you should be sure that, sir, here and all force cannot be 0. You know why? Because there are 2 charges to apply force on Q0. 2 charges to apply force on Q0. And force is a vector quantity. If 2 forces are equal and opposite, then only they can become 0. And opposite means 180 degree. If you take any point here, this Q will repel, this 4Q will repel, and there will be some angle between the forces. So definitely you will get net force. So net force cannot become 0 here and there. It can become 0 only on the line. Because the forces has to be opposite and equal. For net force to be 0, the forces has to be equal and opposite. I hope you are understanding. So force can never become 0 here, 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 here. It can become 0 only on the line joining the charges. So what I will do, first I will check here. Okay. First we will check here. Let's keep the charge Q0 here. Now sit on Q0. You sit here. What you will see, this positive charge will repel Q0. That is also positive. That will also repel. So both the charges are repelling Q0. And both the forces are in same direction. If 2 forces are in same direction, they cannot be 0. Net force cannot be 0. Here I will not get equilibrium point or null point. Then come here. What about this point? Positive will repel. Force because of this is also positive. Positive will repel. Both will repel. Net force cannot become 0 because both the forces are in same direction. Now come in between. Here, let's say here. Charge is Q0. Now, this is a positive charge. This is positive charge. So this Q will repel Q0. Is it? Force on Q0 due to Q. This is positive. This is positive. This will also repel away. This is force on Q0 due to 4Q. You can see both the forces are opposite. If I make them equal, net force will be 0. Is it? I don't know where the force will become 0. So let's assume that this distance to be x. If this is x, what will be this distance? Total is L, this is x. So this will be L minus x. So both the forces are opposite. I have to just make them equal. Means the magnitude of force on Q0 due to 4q, if I make it equal to the magnitude of force on q naught due to q, if I make both the force equal, as they are opposite, net force will be 0. Let's write the force. What force q naught will experience because of 4q? So force is k, charge is q naught, other charge is 4q, divide by distance between them, L minus x square, L minus x whole square, which is equal to force on q due to q naught. So force on q due to q naught. So k q naught, k q naught divide by distance between them square. What is distance between them? X. So x square. K q naught q 4 upon L minus x whole square is equal to x square. Take root both the sides. If you take root, so 2 upon L minus x is equal to x. So from here, what you will get, is it correct? Yeah. So therefore from here, 2 is equal to Lx minus x square. Do one thing. Don't make quadratic. You do one thing. You write, bring this, one second, I think I have done some mistake somewhere. K q naught upon, no, correct. This got cancelled out. Oh, sorry. This is 1 by x square, my bad. 1 by x square. Now, so just take root both the sides. 2 upon L minus x is equal to 1 by x. Cross multiply. So 2x is equal to L minus x. So 3x is equal to L. So x is equal to L by 3. X is equal to L by 3. So here x is equal to L by 3. So you will get the equilibrium point. This x is L by 3. At a distance of L by 3 from Q and between the charges. When this question will come, if this question comes, chances there, a lot of questions they have given based on this. Be very careful from which charge they are asking. So your x is from Q. So L by 3 from Q. So from 4Q, L minus x. So L minus L by 3 will be 2L by 3. They will keep both the options. In fact, they will write on the left, on the right. So check the options very carefully. You can write on the top. If this question comes, check the option very carefully. So L by 3 from Q or 2L by 3 from 4Q. You can write this. You can complete this fast. Okay. Next problem. You know, I can give you one trick also here. One trick is there. You can just write the trick. When two charges are of same sign, both plus or both minus, when both charge is plus or both are minus, then equilibrium point will always come between them. You can see outside the forces were in same direction. So when charges has same polarity, both are plus or both are minus, same polarity, then equilibrium point from smaller charge will be root of small charge upon root of large charge plus root of small charge multiply by distance between the charges. On solving this, you will get the equilibrium point from smaller charge. And when the charges are of same polarity, the equilibrium point comes between the charges. Write this. When charges are of same polarity, the equilibrium point comes between the charges. And this is mod. If it's a negative charge, take the mod. Clear? You can check. Look at this problem. Smaller charge is what? Check. Smaller charge is Q. So root Q. Divide by what is larger charge? Root 4Q plus root Q into distance between them, which is L. So what you will get? Q cancel out. Root 1 will be 1. Root 4 will be 2. Root 1 will be 1 into L. You got L by 3. From which charge? Equilibrium point from smaller charge. Is it clear? Okay, fine. Next, you can write, pause and write. Next, we will talk about equilibrium point when the charges are opposite in polarity. Let me give you one problem on that. We have a charge 4Q and let's say we have a charge minus 9q. Distance between them is L. I want you all to find out what will be the equilibrium position for a charge q naught, or where should I place a charge q naught so that it does not experience any force. Pause and try. Okay, again same. First you make a line joining them. Now let's see, if I keep the charge q naught somewhere between them, then what will happen? Positive charge will repel, throw it away. Negative will attract. Both the force are in same direction. We cannot achieve equilibrium. Now come here. What about this point? Negative will attract. Positive will repel. Oh, both the forces are opposite. Force because of 9q on q naught, and repel force because of 4q on q naught. Okay, let's come and check this point. At this point, what will happen? Positive will repel, force because of force on q naught because of 4q, and negative will attract, again force on q naught because of minus 9q. Again forces are equal, forces are opposite. Here also forces are opposite. If forces are opposite and equal, then net force is 0. There are two conditions. They should be equal and opposite. Now the thing is, you will say, sir, there also forces are opposite. Here also force is opposite. So we can get two equilibrium points. The answer is no. Why no? You know, the formula of force is, try to understand, listen very carefully, K q1 q2 by r square. Is it? Our one charge is q naught. One charge is q naught. So when 4q is applying force, it's a force between q naught and 4q. And when minus 9q is applying force, it's a force between q naught and minus 9q. Means q naught is getting two forces. One because of 4q, one because of minus 9q. So force depends upon the charge which is applying force. Force on a charge depends upon the other charge which is applying force, as well as the distance between the charge. Now to make net force 0, when two charges are applying force, to find net force 0, basically what we are doing, one charge is dominating charge wise and one charge is winning because of less distance. Less distance means more force. What I am saying, like at this point, you know, net force cannot be 0. Try to understand why. 9q, minus 9q and 4q, which is a stronger charge? Minus 9q is a stronger charge. Is it? More in magnitude. It will attract more. So charge wise, who is winning? Minus 9q. Here, charge wise, who is winning? Minus 9q. And you take any point here, that point will be closer to minus 9q and far away from 4q. So distance is less from 9q. If distance is less, then also force is more. It means in this entire region, the force of 9q will dominate. Forces will be opposite, but one force will be more. Are you understanding? Forces are opposite, but they can never become equal. Why? Because in this region, force formula is what? K q1 q2 by r square. Q naught is experiencing force. Who is applying force? Minus 9q and 4q. In this region, minus 9q is more in magnitude, always. So because of charge, who is winning in these two? Minus 9q. And if you take any point here, it will be closer to minus 9q and far away from 4q. So less distance means more force. So 9q is dominating because of both more charge and less distance. So force of minus 9q will be always more. Force will be opposite, but always who will dominate? Minus 9q. Now come in this region. In this region, 4q will dominate because of distance. Less distance means more force. And minus 9q will dominate because of charge. So one is winning because of charge and one is winning because of less distance. Here force can become equal and opposite. So net force will be 0 in this region. I hope you are understanding what I am saying. Is it clear to everyone? What I am saying, if you keep the charge here, Force depends upon the charge which is applying force and the distance. So in 4q and minus 9q, 4q is repelling, minus 9q is attracting. Who is winning charge wise? Minus 9q, more charge. And 4q is cancelling out that extra effect because of less distance. From q naught, distance is less. From minus 9q, distance is more. So less distance means more force. So 4q is dominating because of less distance. So we can get a point where forces will be equal and opposite. Let's say that this distance is what? X. So forces are opposite. I have to just make them equal. So how much force 4q will apply? K q naught 4q divided by distance is x square, which is equal to how much force minus 9q will apply? K q naught 9q. Don't write minus sign. I have told you minus means direction, which I have shown attraction, by this is L, this is x, so L plus x whole square. K q naught q, K q naught q. Take root. If you take root, what you will get? 1 by 4. So 2 by x is equal to 3 upon L plus x. Cross multiply. So 2L plus 2x is equal to 3x. So x is equal to 2L. This will be your answer. So this x will be 2L. So from 4q on the left, at a distance of 2L, I will be achieving equilibrium point, null point, or net force 0 point. So read very carefully from where they are asking. If they ask from minus 9q, then 2L plus L, 3L. Clear? Here also we have a trick. When charges are equal and when charges are opposite in sign, one is positive, one is negative, then equilibrium will be outside. First you write equilibrium point will be outside, not between them. Outside and closer to a smaller charge. So equilibrium from a smaller charge. This is trick. Equilibrium from a smaller charge will be root of q small divided by root of q large minus root of q small into distance between them. You can check for this. Root of q small, take the magnitude if they are negative. What will be root of q small? Smaller charges 4q. So root of 4q will be, so q cancel out, root 4 will be 2. And root large, root 9 will be 3 minus root 4 will be 2 into L. This will be what? 2L. Is it clear? And you have to understand this. Every time equilibrium point will come close to a smaller charge, because the larger charge is more in magnitude, it will apply more force because of charge. So smaller has to take what? That point closer to it. So because of less distance, smaller will dominate and they can nullify each other's force. Is it clear to everyone? You can pause and write. Clear? Okay. Now I will show you some more questions in which some series will come. Okay, let me show you some problems. Okay, before that, one more question I want to give you. Let's say we have a charge q and 4q. Okay, and they are at a distance of x. At the center, I am keeping a charge small q. You have to find small q in terms of capital Q so that entire system remains in equilibrium, so that entire system remains in equilibrium. Pause and try. Done? See, first you read the question very carefully. I am not saying the center charge to be in equilibrium. I am saying entire system to be in equilibrium. Entire system to be in equilibrium means this charge, this charge, this charge, all has to be in equilibrium. All charges has to be in equilibrium. Do one thing, make this charge Q. make the top charge Q. Now try. Now try. So I want the entire system to be in equilibrium. It means on each charge the net force should be what? 0. Now you know this center charge Q will be always in equilibrium. Whatever you take Q, 2Q, 4Q, minus Q, whatever, because on this charge whatever force this will apply, same force this will apply in opposite direction. So center will be always in equilibrium if the charge is at the center. Okay, find Q in terms of capital Q so that the system is in equilibrium. This is kept at the center of these two. This is kept at the center. Okay, let me write here. This Q is placed at the center. So this will be x by 2. This will be x by 2. This is given in the problem. Now for the system to be in equilibrium, I want this charge also to be in equilibrium, this charge also to be in equilibrium. Okay, now how to bring this charge in equilibrium? If you check the problem, on this charge who will apply force? On this charge Q will apply force, capital Q will apply force. Okay, now what force this Q will apply? Now these two forces are same. So this force, this charge will repel this charge. By what force? It will repel by K, Q, Q by, what is distance between them? X, x square. Is it? If this charge is repelling this charge and this charge has to be in equilibrium, so this charge has to attract this charge. So one thing I understood, if these two are positive charge, this has to be negative because this will repel. So this has to attract. For equilibrium, net force has to be 0. So this charge will attract this charge. By what force it will attract? You will write, sir, K, Q, Q by distance between them square, x by 2 square. So x square by 4, 4 will go on the top. If these two forces are, they are opposite. If these two forces are equal, net force will be 0. Just make both the forces equal. So K, Q, Q by x square is equal to 4k q by x square. X square, k q. What you got? So small q will be capital Q by 4. In the formula we have just put the magnitude. Sign we have to find with common sense, and as I told you, this charge is repelling this charge, so this has to attract. It means Q is negative, so put here minus Q by 4. So Q will be what? Minus Q by 4. Is it clear to everyone? You can pause and write. So now whatever charge they give, whatever position they give, just do the same thing. Take this charge, find the net force on this, make it 0. Clear? Right force equal to left force. Next. Let's do some series problems like this is origin. On origin I have kept a charge 1 coulomb. Okay. Now here I am keeping a charge 1 coulomb. Here I am keeping a charge 8 coulomb. Here 27 coulomb, and so on. Here I am keeping 1000 coulomb. At what distance? This is at 1 meter. X coordinate is 1 meter. This is at 2 meter, 3 meter, dot dot dot. This will be at 10 meter. Find net force on 1 coulomb. Pause and try. Net force on 1 coulomb. Done? So what you will do? You will say, sir, positive, this 1 coulomb will repel 1 coulomb. Positive will repel positive. Is it? What about 2 coulomb? Sorry, what about 8 coulomb? Positive, positive. It will also repel. 27 coulomb, repel. All forces will repel. All charges will repel. And they all will repel in same direction. Because line joining all the charge is same. Line joining will be same. So all the force will be in same direction. When the forces are in same direction, we can directly add them. So what will be net force? So net force will be force because of first charge, second charge, third charge, fourth charge, addition of that. How much force first charge will apply? K, Q1, Q2, 1, 1, by distance square, 1 square, plus what for second will apply? K, Q1, Q2, 8 into 1, divide by distance square, 2 square will be 4, plus how much force third charge will apply? K, Q1 Q2 divide by distance square. Distance between them is what? 3. 3 square will be 9 and so on till the last charge. Is it? So what I can take common from here? So net force will be, I can take K, this is 1, just write it as 1, divide by, see this will be 1 za 2 za. This will be 9 1 za 9 3 za. And for the last charge what you will write? For the last charge K 1 into 1000 divide by 10 square. 10 square will be 100. So 10. You can see if I take K into 1, this 1 Coulomb common, I will be getting, if I take K and this 1 in all common, I will be getting here 1 plus here 2 plus here 3, 4, 5, 6 and last I am getting what? 10. Is it? So what you will get here? Net force will be what? Net force will be, we write in terms of K only. K, what will be summation of this? Summation of this, I hope you all know, n into n plus 1 by 2. N is the number of term. What we have? 10. So 10, so K into 10, 10 plus 1, 11 by 2. This will be 55K. So net force on 1 Coulomb will be what? 55K. And in the vector form if you want to write, you can see all the forces are left. All the forces are left. So net force will be minus 55K I cap. Pause and write. Clear? In fact, I want you all to remember some formulas like 1 plus 2 plus 3 plus dot 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 dot. What is summation of this? Till n. Summation is n into n plus 1 by 2. If we have 1 square plus 2 square plus 3 square plus dot dot dot, summation of this will be n into n plus 1 into 2n plus 1 divided by 6. Remember this. If you know the concept, if you know the solution, how to solve the problem, but if you don't know how to do summation, you will not get marks, is it? You cannot sit and add there, na? Okay, fine, it was till 10. But if it is till, let's say 1000, 1500, 2000, then you cannot add, is it? In fact, I will prefer you to remember 1 cube plus 2 cube plus 3 cube plus dot dot dot. This will be n into n plus 1 by 2 whole square. Remember these three. Clear? Pause and write. Let's do the next problem. Next question. Now suppose again we have here one charge 1 Coulomb. At 1 meter we have charge 1 Coulomb. At 2 meter we have charge minus 2 Coulomb. At 3 meter we have charge 3 Coulomb. At 4 meter we have charge minus 4 Coulomb. Dot 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 till infinity. What will be the net force on 1 Coulomb? Find net force on 1 Coulomb which is at origin. Pause and try. So what you will get? Listen, one thing is very important here. 1 Coulomb will repel. Force on 1 Coulomb due to 1 Coulomb. Is it? F1. Minus 2 will attract. This is force due to minus 2. 3 is positive. Positive, positive, repel. Now this is force due to 3 Coulomb. Minus 4 will attract. Now this is force due to minus 4. Then 5 will repel, 6 minus 6 will attract and so on. Is it? So all the forces because of 1 Coulomb, 3 Coulomb, 5, all the positive charges force will add up and all the right forces negative will add up. Positive in left, negative in right, then we will subtract that. Is it? That's what we will do. Because one force is coming right, left, right, left, right, left, right, left, right. Is it? So can I write like this? Net force will be K. How much force first charge will apply? K. 1. First charge is also 1. It's at 1 meter, so 1 square will be 1. Then minus 2 will attract. 1 has repelled, minus 2 has attract. Both are opposite. So subtract minus K 1 and 2 Q1 Q2 by 2 square 4. Now 3 Coulomb will repel plus K Q1 Q2 by 3 square will be 9. Now minus 4 Coulomb will attract. So I am writing left as positive, right as negative, because left is more, na? 1 Coulomb will apply more force. Minus 2 will apply less, because here charge is 1, distance is 1. Here charge is minus 2 and distance is 2. So charge has doubled. So force will become 2 times, but distance also doubled. So force decreased by 4 times. So force is decreasing if I compare these two. Then in these two also, positive will apply more force, negative will apply less force. That's why plus, then minus K. First charge is 1, second charge is 4 by 4 square 16 and so on. You can see if I take common K into 1, what I am having 1, then minus, here we have 1 by 2, then what we have 1 3 plus 1 by 3, 4 ones of 4 fours of 16, minus 1 by 4 plus 1 by 5 and so on. Now you know what is this series? 1 minus 1 by 2 plus 1 by 3 minus 1 by 4. This is series of ln 1 plus x. I want you all to remember. Remember this, very important. What is expansion of ln 1 plus x? It is x minus x square by 2 plus x cube by 3 minus x power 4 by 4 and so on. This is expansion of ln 1 plus x. Now if you see, if I put x value 1, what I will get? Have a look. Ln, if I put x value 1, 1 plus 1 will be 2, which will be 1 minus 1 by 2 plus 1 by 3 minus 1 by 4. So what we got? This is basically ln 1 plus 1, which is ln 2. This series is what? ln 2. So you will be getting K and summation of this will be ln 2. This will be the net force. Now if this question came, 99% will reach till this point, but hardly 1% will know this expansion. I hope you understood. Pause and write. Okay, we'll do one more question in this lecture, and then remaining questions I will bring in the next lecture. Next lecture will contain even better questions, SHM, okay, time period questions. Then we have some graphical questions, integrations and all. Next question is, even I will try to connect with friction, circular motion. Okay, now we have a charge Q1 which is fixed here, and at R1 distance we have a charge Q2 which is just released. At t equal to 0, this is released. So we were having a charge Q1 which was fixed here. I brought a charge Q2 and released. Release means initial velocity will be 0. What will be the velocity of Q2? Now what will happen? Q1 is fixed. Q1 will repel Q2. Q2 will repel Q1, but I have fixed Q1 anyhow. Leave it. So Q1 will repel Q2. So Q2 will start to move. You have to tell me when Q2 will reach R2 distance, what will be the velocity of Q2? Find out what will be the velocity of Q2. Pause and try. See how to solve. So Q1 and the mass is m. Mass is m. Mass is m. Now if you look at this problem and don't take the gravitational force, the gravitational force, if you remember the first question which we did, the ratio of electrostatic force to gravitational force came how much? Somewhat 10 power 40. So if distance is not much, even distance will not matter. R square gets cancelled out. So this electrostatic force is very high as compared to what? Gravitational force. Okay, unless the masses are very large, very big. Okay, so we have to ignore gravitational force between them. Don't take that into account. Okay, only take electrostatic force. So Q1 will repel Q2, Q2 will move. You have to find the velocity of Q2 when the separation between Q1 and Q2 is R2. So see, if you look at this, as the distance will change, as Q2 will move from this position to this position, distance will continuously change. If distance will change, we know the formula of force is K Q1 Q2 by R square. If distance is changing, it's a variable force. So what I will do, I will go to a random distance x. Will go to a random distance x, and I will find what will be the force here. So what will be the force here on Q2 at random distance x? Force will be K Q1 Q2 by x square, where x is the random distance. Is it? Now you think I need to find out velocity. For velocity I know force. Let's find out acceleration. So acceleration, force is mass into acceleration. So acceleration will be K Q1 Q2 by x square into m. I want velocity. Can I write acceleration in terms of velocity? Yes, we can write. Acceleration is dv by dt. But one problem is there. Time came. They have not mentioned about time and all. They have mentioned about distance. So I need to write acceleration in terms of displacement. Distance or displacement. Moving in a straight line, both will be same. So I have to write acceleration in terms of displacement. So what I will do, I hope you all know this. If I multiply by dx and divide by dx, any problem? No. And what is this dx by dt? Velocity. So acceleration is v dv by dx. Now I can relate v and x. Is it? If I put acceleration as v dv by dx and dx I send there, I will get k q1 q2 by mx square into dx. Is it clear? Understood? Now what I will do? Integration. What I will do? Integration. Understood what I have done? I saw that force was continuously changing because force depends upon distance. When charge will go from R1 to R2, distance will change. So I went to a random point. I wrote force as a function of distance. But I want velocity and distances are given. So I wrote force in terms of acceleration. And from acceleration, I related velocity and displacement. Now I will integrate. What is lower limit? What is lower limit? They have released the particle here. Release means initial velocity is 0. At what distance? Distance is r1. And finally particle velocity is, let's say, v. And final displacement from r1, particle went to r2. Final displacement will be r2. Clear? Pause and write till here. Try to solve by yourself. What will be integration of v dv? Integration of v dv will be v square by 2. 0 to v is equal to k constant, q1 constant, q2 constant, mass constant, integration of dx by x square, which is x power minus 2 dx. Integration of x power minus 2 dx will be x power minus 2 plus 1 divided by minus 2 plus 1, which will be minus 1 by x. Limits from where to where? R1 to R2. So this will be v square by 2. Lower limit will be 0, which is equal to k q1 q2 by m. This will be, if I remove minus, limits get interchange. So this will be 1 by r1 minus 1 by r2. And from here, the velocity will be root of 2k q1 q2 by m 1 by r1 minus 1 by r2. I hope you all understood. Pause and write. You know, same question I can do in one line. But for that, you need to learn the upcoming part, potential and potential energy. Okay, this question can be done. So I will take there, no need to worry. In one line, I can solve this question. No need to solve this much. No integration is required. And that's why potential energy we learn in class 11th. To save our time from integrations, big integrations. Clear? I hope you understood. I hope you like this video. In next video, I will bring some more even better problems. Okay, no need to worry. So just write down any doubt, write in the comment section. I will take care of that. Clear? So what I have done here, from here to here charge was going. I have to find the velocity here. I observe that when the charge is moving, distance is changing, force is changing. It's a variable force. So I wrote force in terms of what? Displacement. I got force, but question is asking velocity. I wrote force as mass into acceleration. Acceleration I got. Now acceleration I can write in terms of velocity. I know acceleration is dv by dt, but there is no time mentioned. I have to relate velocity with displacement because r1, r2 is given in the problem. If with time they ask, I will write dv by dt, but they have given displacement. So I wrote acceleration as v dv by dx, v dv by dx. I brought dx here, I integrated, initial velocity 0, initial position r1, final velocity v, final displacement is what? From here to here, final distance is what? r2. So integrate from r1 to r2. I just integrated, I got the velocity of v. Is it clear? So keep studying. Okay, we'll meet in the next lecture. All the best. Bye.